Okay then. Here we go. So there are a couple things that you need to remember when you're working with exponents. Okay. First thing, you can multiply. You can add exponents when bases are the same. So bases have to be the same when you add them, when you multiply. Bases have to be the same when you're dividing to do your exponent rules, okay? So we're gonna go over exponent rules. And the second thing is that when you're working with rational exponents, the denominators need to be the same in order to add them or subtract them. So we're gonna start with this one. P and P are bases. They're the same, so that means when we multiply them, we can add exponents, okay? Now we have to look at our exponents. 1/4 and 9/4. Do they have the same denominator? They do, so we can add them. So 1 plus 9 is 10, and I'm just going to put 4, okay? Because remember, you don't add denominators. You leave them alone. The only time you do anything with denominators is when you're multiplying. Now, the next thing that you have to do, because this is a rational exponent, is the exponent needs to be reduced. You can't leave a rational exponent that can be reduced. What can you reduce 10 and 4 by?
2.
So 10 divided by 2 is,
5.
and 4 divided by 2 is?
2.
That's your final answer. If it starts with a rational exponent, and it will end with a rational exponent. If it starts as a radical, it ends as a radical. Yes?
So when I was doing my homework on these types of problems, I had done...
So it's n to the 2/3 times n to the 8/5. So that's 8/5, you guys. So 8/5. Okay. The ends are the same, so those bases are the same. So that means that we could add exponents. The problem is that our exponents are fractions, and we can't add fractions unless they have common denominators. They have like denominators. So I need to make 3 and 5 into the same denominator. What can I change a 3 and a 5 into so that they're the same? 15. So how do I change a 3 into a 15? So I'm going to multiply the top. I'm going to multiply the numerator by 5 and the denominator by 5. I'm going to multiply, what am I going to multiply 8/5 by?
3.
So remember, you can only add exponents when you're multiplying if the bases are the same. So n is our base, those are the same. But you can't add fractions unless the denominators are the same. So that's what we did. We changed our exponents so the denominators were the same. So now we can add them. So the n stays. And what is 10/15 plus 24/15? 34/15. 34 and 15 can't be reduced, so we're going to leave it like that. Okay. Now, if it was an actual number, you guys, then we might try to take the root of it and try to get it smaller than it is. But because it's just a variable, we're going to leave it like that. It started with a rational exponent. It's going to end with a rational exponent. Okay. Example 13. Okay. So, in math, or in Algebra 2, we've talked a lot about what you can't have in the denominator. And we've also talked about negative exponents. Okay, so you should never have a negative exponent. So that's the first thing that we're going to deal with. Since the number in front of r is 1, since there's nothing there, it's 1, we're going to rewrite this as 1 over r to the 4/5. Okay, so that's the first thing, is no negative exponents. The second thing is that there should be no rational exponents in the denominator. What that means is there should be no fractional exponents. Like you shouldn't have a fraction exponent in the denominator. Now, so this is kind of like rationalizing. I need to make the exponent on r 1. So what's the denominator of my fraction? What's my denominator of my fraction? 5. Okay, what can I add to 4 that will give me 5? What is it? 1. So that means I'm going to multiply the top, the numerator. I'm going to multiply the numerator and the denominator by r to the 1/5. Because remember, whatever you do to the denominator, you have to do to the numerator. And because I'm trying to get rid of the fraction in the denominator, okay, so this becomes r to the 1/5 over r to the 5/5. Well, what is 5? What is 5 over 5?
0.
No. It is 1. So it's just r to the 1/5 over r. That's your answer. Those are fun, right?
No,
I think we should do another one of those, don't you?
not really.
Okay. Let's do, I'll use x, so we'll use x. Okay. So it has a negative exponent, so what does that mean? I need to do what? Well, what did I do here? I write it as a, you guys, what do I write it as? A fraction. What's my numerator? 1, 2, 3, 4, 5, 6. It's 1 over x to the 2/3. The reason it's 1 is because there's no number in front of the x. Now, I have to decide what to multiply by so that I can get a numerator of 3.
1/3.
So I'm going to multiply x to the 1/3 over x to the 1/3. Remember, you're just trying to get the numerator and the denominator to be the same. X to the 1/3 over x to the 3/3. And then that's your answer. So at this point, are there any questions about how I did something or how I got rid of something? Okay. I'm going to combine a lot of things in this one problem. Okay. So when you get a problem, there's going to be some stuff in this one that will help you with other things. I know that probably didn't make sense, but there's steps in this one that will look like something you're doing tonight on your homework. Okay. What do you notice about this fraction?
Has radicals.
Has radicals. What else do you notice? right? Well, you notice that the roots, the indexes are different. Okay, you guys, it started as a radical. That means our final answer is going to be in radical form. Okay, so what we have to do is we're going to have to rewrite this. So what we're going to do is we're going to write 32 to the 1/4 over 2 to the 1/3. So that's what we did last night for homework, okay? Now what we're going to do is, remember I told you, you can divide if bases are the same, right? If the bases are the same, you would subtract the exponents. But our bases are not the same. So here's my question. Is there a way, I can't rewrite 2. 2 is the smallest, it's like, I can't go any lower than 2, except for 1, but I can't make a 2 into a 1. Can I make a 32 into a 2? Like, is there any, like, can I raise 2 to a power to get 32? That's what I'm asking you. Can I change 32 into a 2? Yes. So I'm going to rewrite 32 as 2 to the 5th raised to the 1/4. So now I'm getting closer for my bases being the same. But you guys, what am I going to do with the 5 and the 1/4? So the exponents, my base is 2, but what am I going to do with the 5 and the 1/4? What do I do with those two? Brandon. So now I'm going to have 2 5/4 over 2 to the 1/3. Now, you guys, I actually can divide the 2's, and what you do with the exponents, since the bases are the same, it's a fraction, we're going to subtract the exponents. But what's wrong with the exponents?
Not the same.
What do you mean they're not the same?
One's not the same.
The denominators are not the same. You have a 4 and you have a 3. So how can I make 5/4 and 1/3 both have the same denominator? What can I multiply 5/4 by? So I'm going to multiply this by 3. And what am I going to multiply 1/3 by? So I have 2 to the 15th over 12 over 2, 4 to the 12ths. Okay, so you guys, again, the only reason we had to change the denominators because you can't add or subtract fractions unless the denominators are the same. And you can't divide unless the bases are the same. Well, I have 2 over 2, so the 2 is going to stay. What is 15 minus 4? Okay. So 15 minus 4 is 11 and 12. Now, here's my question. Am I done? I would be done if I had started off with rational expressions, but I started off in radical form. So, one more, and then we're done with this one. Where does the 2 go? The big 2. Where's the 2 go? Inside the radical. What goes in the check mark? The 11 or the 12? So the 12 goes in the check mark. And then the 11 goes here. This is your final answer. So 12 is in the check mark, you guys. I know you can't read that. That's your final answer. That's a little bit better. You can read that one. Okay. There any questions so far? Okay, so I'm going to do this. We're not going to use rational exponents for this one. I actually think it's easier to do what we were doing before. in section 6.5. So the question becomes, Ms. Fleury, when do we know? It's just, I might tell you on your test, use rational exponents, okay? I don't think it's really going to matter, but let's do this. This would be section 6.5. So what I'm gonna do is I'm gonna break this up. So we're gonna break it up into the cube root of 16 times the cube root of x to the fourth. You guys, the cube root or the index tells us how many of one number we need. Okay, so we're gonna do a tree just like we normally do, okay? So two numbers you can multiply to get 16. Okay? Okay, what are two numbers you can multiply to get 4? Okay, usually when we're dealing with square roots, we're looking for pairs. But because we're looking for, since our index is 3, we're looking for 3 of the same number. Do I have 3 of the same number?
Yes.
What do I have 3 of?
2s.
So I have 3 2s, so I'm going to cross those out, and I'm going to put that on the outside. And then do I have something that was left, that I circled, that's left over?
Yes.
What?
2.
Okay. Now, that's done for the 16. Now we're going to worry about the 4. Okay. I have the cube root, so 4 divided by 3 doesn't work. Is there a multiple of 3 that is less than 4? 3. So we're going to break it up into the cube root of x to the third times the cube root of x to the fourth. What is 3 divided by 3? So that becomes x. Can we take the third root of, you guys, I'm really sorry, this should be x. So it should be x to the third times x. I apologize. So I broke it up into the x to the third and x. In my head I was thinking 4, sorry. And then what's left over? The cube root of x. Okay, what is left on the outside? So what's on the outside of this problem? 2 and x. What's left on the inside? 2x. That's my answer. Okay, you ready for the last example? Okay, here we go. What do you think we have to multiply the denominator by? What's that word that we've been talking about anytime we try to get rid of something in the denominator? Conjugate. Okay, so what is the conjugate of y to the 1/2 minus 2?
Y to the 1/2 plus 2.
Yep. Y to the 1/2 plus 2. So you're going to FOIL the top. So you're going to do y to the 1/2 times y to the 1/2. The bases are the same. So you would get y 1/2 plus 1/2 is 2 over 2. 1 plus 1 is 2. Remember, we don't add denominators, even though in first period I did. What's 1 to the y to the 1/2 times 2? 2y to the 1/2. Y times 2 is 2, and then you just add the exponent. What's 2 times y to the 1/2? And then what's 2 times 2? What's 2 times 2? And remember, you guys, because they're conjugates, which is a form of a difference of squares, the reason you do that is because it eliminates the middle term. So when they're conjugates, only when they're conjugates, you can multiply the first two numbers, or the first two terms. So y to the 1/2 times y to the 1/2 is y to the 2/2 minus 4. Okay, this becomes y, because 2 over 2 is 1, plus 2 plus 2 is 4, y to the 1/2 plus 4, all over y minus 4. Because 2 over 2 is 1, so I don't need that, and I just bring the 4. 2 over 2 is 1, and remember, when you add, you don't do anything with exponents. When you add, you don't do anything with exponents.